Yes, dear students, now there are two questions. My aim here is to acquaint you with the type of question which are asked in different competitive exam here. So prepare yourself from the very beginning in class 11 for this purpose of competition. Actually, people come in the mood of appearing the competition after being class 12. But why don't we start from initial? The first question is there, a particle is moving on circular path of radius A under the attractive potential U is equal to minus K upon 2R square. What is its total energy? This question has been asked in JEE 2018. Second question again it is NEET. NEET 2018. Now there is nothing, little effort, more effort is required for this purpose. Question answer of 1, है ना? Answer question number 1. By U given by minus K upon 2R square. I told while teaching conservative force, we know F equal to minus dU over dr. If by potential energy potential is there when force acting, and force is equal to negative gradient of potential energy dU over dr minus d upon dr of K upon 2R square. Here K is constant, R is the distance from center. अगर ये circular path है तो R is the distance from, suppose it is here, and K is constant. So it will be minus K upon 2 dr of R to the power minus 2, which will come out to be equal to K by 2 into minus 2 R to the power minus 3. So it is minus K plus K upon R cube. The force here acting on this is given by this. Since body moving on circular path, and on circular path central force required, we know F equal to mv square by R. So we can write here mv square by R is equal to K upon R cube, or mv square is equal to K upon R square. Okay, now kinetic energy of particle, moving with velocity v is given by K equal to half mv square, and v square equal to, putting this value of mv square here, half K upon R square. So if R is equal to A, then total energy is equal to K upon 2A square. So dear students, please try to do such questions. A little effort, not a large extra effort is required. Some topics actually teachers do not teach in the class, taking that they are optional, but optional questions are asked in competitive exams. Now there is another question number 2 here, a good question. Actually, my aim is to explain something extra to you here. A moving block of mass m collides with other stationary block of mass 4m. The lighter block comes to rest after collision. What is coefficient of restitution of the collision? Assume the initial velocity of moving block भी v. हमारा ये कोई मूविंग बॉडी है मास m की, it collides another ball of mass 4m. After collision, this 4m start moving with certain velocity, say v dash, and m comes to rest. And for this v is equal to 0. Initial velocity is v. So in your brain, a question may come out in brain where it is not given here collision is elastic or inelastic. Actually, this coefficient of restitution is the measure of elastic nature of the collision. It itself tell you the nature of collision, whether to what extent the collision elastic, and the restitution, coefficient of restitution E लिखते हैं, is equal to ratio of velocity of separation divided by velocity of approach. When two bodies collide, to what extent the collision between them is elastic or perfectly inelastic. So that is measured in terms of this E. You know, for perfectly elastic collision, velocity of approach is equal to velocity of recession, means departure. So for that E is 1. For perfectly elastic collision, you know, we have proved there that velocity of approach is equal to velocity of separation. So for perfectly elastic collision, perfectly elastic collision, E equal to 1, and for perfectly inelastic collision, E is equal to 0, because you know in perfect elastic body get embedded together and move with constant. They don't get separated, so their velocity of separation 0. My aim here is to tell you this thing, because in general teaching coefficient of restitution is not taught by teachers. Now where we have to find out here. So in every collision momentum is conserved. So m into v plus 4m into 0, उसकी initial velocity 0 is equal to 4m into v dash plus m into 0. Mass m comes to rest. From here mv equal to 4mv dash. So v dash equal to 1 by 4. Into v. So v dash is the velocity of recession or separation, and hence E is equal to v by 4 upon v equal to 1 by 4. So here is equal to 0.25, or you can say it is 25% elastic collision. So this was my aim here to tell this question to you. Now you try question from work power energy yourself. This is a good chapter for competition purpose. In every competitive exam, question is always there from work power energy, and simple concepts are there. So thank you, and we meet now in next chapter with next chapter, rotational motion.